Example 7.4, the track length of a compact disc. In a compact disc player, as the read head moves out from the center of the disc, the angular speed of the disc changes so that the linear speed of the position of the head remains at a constant value, v tangential, of 1.3 meters per second. Find the angular speed of the compact disc of radius 6 centimeters when the read head as at r equals 2.0 centimeters. R sub naught, let's call it, is 2.0 centimeters, and R sub final is 5.6 centimeters. And I might have those reversed. It might have start at the outside and go inside, like a record player would. So these both will use V tangential equals R omega, and we will do the first one will be omega equals V tangential over R naught, which is, I need to start over on further to the left on these cards. So that is going to be 1.3 divided by 0.02, which is 2 centimeters, which is 65 radians per second, approximately 10 revolutions per second. All right, and then the second part, omega is 1.3 divided by 5.6 centimeters, which is 0.056 meters, or 23.2 radians per second, rad per second, and I put an extra point in there, and that's about a little over 2 revolutions per second. Okay, and then for part B, we've got an old-fashioned record player rotating at a constant angular speed, so this time omega is constant. So the linear speed of the record groove moving under the detector changes. Find the linear speed of a 45.0 RPM, revolutions per minute, record at points 2.0, so R equals 2.0 centimeters, and let's call it R1, and R2 is 5.6 centimeters. Find the linear speed. So first let's convert our omega into radians per second. So we've got revolutions on top, radians. So we got to convert that to radians, 2 pi radians per revolution. And then we got minutes on the bottom, so I'll put minutes on the top and seconds on the bottom. So we will have 60 seconds in 1 minute. And that comes out to be 4.71 radians per second, which is well less than a full revolution per second. All right, for radius of 2 centimeters, V tangential is going to be equal to R omega, which is 0.02 times 4.71. And for R2, V tangential is R omega equals 0.056 meters times 4.71. So this one was 0.094 and this one was 0.26. meters per second, or 9.4 and 26 centimeters per second. Part C. In both the CDs and the phonograph's records, information is recorded in a continuous spiral track. Calculate the total length of the track for the CD designed to play for 1 hour. Well, for that we had the head was moving at a constant speed of 1.3 meters per second, and we want a distance is velocity times time. So 1.3 meters per second times 1 hour, and 1 hour is 3,600 seconds, or equal to 4,680 meters, which is 4.7 kilometers. If we were asked for the same question about the record player, if it started out as going from 5.6 centimeters to 2 centimeters or vice versa, and it took it an hour to go in that circle, what would the situation be then? We could convert those to linear distances and think in terms of what is the VVXT equation. It would be x equals average velocity times time, which just comes out to be 637.2 meters. Now, a 45 RPM record doesn't have the same dimensions as a compact disc, so you would need to change what the inner and outer radius were for the compact disc to get the actual distance, but that would give you an idea how long the track length was as far as the method goes. So this says, notice that for the record player in part B, even though the angular speed is constant at all points along the radial line, the tangential speed steadily increases with increasing r. So for the CD player, tangential speed was constant, but the motor changes its speed. On the other hand, but the record player, the tangential speed changes, but the motor on the record player moves it at constant speed. So the calculation for a CD in part C is easy because the tangential speed, v sub t, was constant, 1.3 meters per second. It says it would be considerably more difficult for a record player where the tangential speed depends on the distance from the center. Now, my assumption was that it started out at 9.4 centimeters per second, and it ended at 26 centimeters per second, and it increased at a constant speed, and the acceleration was constant. But actually, it moves from this groove to this groove over a long period of time, and then it moves from this groove to this groove over a slightly less period of time. And when you get down here towards the center, it moves from this groove to this groove fairly quickly. Just, or does it? No, it goes in the exact same period of time to go from this groove to this groove as it went from this groove to this groove. It was just that the delta x was longer. So there is some complexity in that question that I did not consider. A is not constant. And so my use of the VVAXT equations was not entirely appropriate because the acceleration is not constant. For now, I will just leave it as it would be considerably more difficult. So, question 7.4. What is the angular acceleration of a record player while it's playing a song? can the CD player have the same angular acceleration as a record player? The angular acceleration of the record player, since it is not changing its constant speed of RPM, so its angular acceleration is 0. Can a CD player have the same angular acceleration as a record player? Based on what we've just learned, the CD's angular acceleration is there's always a constant, or there's an angular acceleration of the CD player to keep it so that the tangential velocity of the read head is 1.3 meters per second. So it couldn't be 0. And exercise 7.4 here. I don't think I'll answer it, or calculate it, but I'll give the equations at least. The linear speed v sub t out of a record player playing at 33 1/3 r rev per min times minute seconds, 60 seconds per minute, and v sub t is revolution minutes per minute times, so that's omega, and then you multiply that by r. So tangential, I usually write it v sub t equals r omega, but that is what you would do. So that goes in a list of equations. S equals r theta, v tangential equals r omega, and acceleration tangential is r alpha.